Welcome to part 4 of our series on the science of flight. Today we're looking at space flight. Since the dawn of human existence, people have looked to the sky in wonder, dreaming of exploring outer space.
Ancient cultures studied the movement of the stars. Science fiction authors created fantastic stories of outer space, and filmmakers brought them to life on the big screen. Beginning in the 1920s, scientists took the first real steps towards space travel. The story of how we reach space is told through the history of each invention, the vision, curiosity, and expertise of engineers, mathematicians, and scientists, all leading to the ultimate goal, space, the final frontier.
Scientific developments like the Laval Nozzle and advances in fuel technology gave rockets the power to defy gravity and leave Earth's atmosphere. Lessons learned from jet engines combined with new technologies to push humans into space.
We're here at the California Science Center to learn about the history and science behind spaceflight. The final episode in our look at how aviation and space exploration have changed the world. Throughout this series, there has been one constant, one common factor that drove innovation, one reality that pushed the boundaries of science. War. In 1940, the German army gained control of most of Western Europe and prepared to invade England.
The shadow of the conquering German armies covered Western Europe. The preliminaries were over. It was time for the main event, the Battle of Britain.
The Battle of Britain began with heavy German bombing raids. When intense aerial bombing failed to crush England's spirit, Germany unleashed its newest war machine. World War II saw the first use of rocket-powered missiles. The German V-2 rocket terrorized England.
A flying bomb over London. For 80 days, beginning 16th June, British defenses faced an average of 100 robots a day.
Bombs dropped from airplanes could be defended against. Air raid sirens signaled incoming bombers. Anti-aircraft guns, air-to-air combat, and underground bomb shelters provided a defensive front and gave civilians a sense of control. The V-2 missile was terrifying. Powered by a rocket engine, it could be fired from a distance of over 200 miles away, and as it traveled faster than the speed of sound, it struck without warning. Rocket technology threatened to turn the tide of the war. The Allied endgame of World War II was focused on destroying the sites where these rockets were made, and, just as importantly, capturing the German scientists and engineers that developed them. As the war came to an end and the Nazi army was nearing surrender, a great deal of effort was put into bringing the German rocket scientists to the West. The Soviet Union was also after the brains behind rocket development, and it is not a coincidence that the future of politics, warfare, and the exploration of space was shaped by the US and the Soviet Union taking in the German minds that drove rocket development. In the final days of World War II, the Soviet Union made a bold move to annex much of Eastern Europe under the banner of communism. This division of Eastern and Western Europe and the ensuing polarization of world power is called the Cold War. Cold because the East and West never fought directly. That doesn't mean things didn't get heated. Instead of fighting each other, they fought indirectly, supporting other governments around the world. Korea, Vietnam, El Salvador, and Afghanistan, just to name a few. The Cold War and the space race pitted two of the world's superpowers against each other in a tense standoff that defined much of our world's history for over 40 years. The battle between two very different philosophies, communism and democracy carried on for decades.
The Cold War finally ended in 1991 with the fall of the Berlin Wall, the end of the Soviet Union, the rebirth of Russia, and the return of democracy to much of Eastern Europe.
Mr. Gorbachev, open this gate. Mr. Gorbachev, tear down this wall.
And now, on with the show.
Something's happening.
Turn on the forward scanner. I think this is it.
Let's get back to our story. After World War II, advances in rocket technology gave the Soviets an early edge in space exploration. In 1957, the USA and USSR both announced programs to send satellites into space.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket.
In 1957, the Soviets struck first with Sputnik, the first satellite to orbit the Earth. The US countered 3 months later with Explorer 1, the first US satellite in space.
Explorer is in orbit, broadcasting to the world its coded scientific data.
Next goal, send a human into space. On April 12, 1961, Yuri Gagarin of the Soviet Union was the first human to enter outer space, making an orbit of the Earth aboard the Vostok 1. Just 23 days later, on May 5th, Alan Shepard became the first American in space.
Freedom 7 is still go, the trajectory is aim.
Having put a human into space, the next stop, the moon.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
From satellites orbiting the Earth all the way to the moon, the competition was fierce and drove scientists and engineers to develop some incredible technology.
Before we head out into space, let's take a look at the science behind spaceflight. In order to get beyond the pull of Earth's gravitational field, you have to have a lot of power. Not only do you have to defeat gravity, you have to do it lifting an enormous amount of weight. Much of this weight is in the fuel itself and the tanks to store it in. So rocket scientists make rockets in stages. As the fuel burns, the lower parts of the rocket detach, literally losing weight as it flies.
Booster separation confirmed. Discovery's guidance is now converged.
A key part of the engine is the Laval Nozzle, the cone-shaped exit of the rocket engine. Most engines generate power by mixing fuel and oxygen, but in space, there is no oxygen to mix, so rockets use special fuels, some liquid and some solid, but all use a chemical mix. That often includes oxygen to burn and create thrust. Here on Earth, most vehicles have internal combustion engines. These engines mix fuel and oxygen to create small explosions in the engine, which then move gears that turn an axle that move the wheels forward. Rocket engines produce raw thrust. The power they create is not used to turn gears. The exhaust exits the rocket, and that force pushes it forward. In order to get the maximum thrust from the exhaust, the Laval nozzle is used to constrict the flow of gases, compressing them and increasing the thrust, which then propels the rocket engine forward. Once you break through Earth's atmosphere, you have to know whether you're going to move in an orbit around the Earth or keep on going to the Moon, Mars, or beyond. Most rockets launch either satellites or people into low Earth orbit. But if there's no gravity in space, what keeps them from flying off into an endless void?
You see, Earth's gravity doesn't disappear when you leave our atmosphere. The pull of Earth's gravity extends, albeit diminished, into space. This gravitational pull, combined with the speed of the object moving in space, is what keeps satellites and space stations in orbit. They travel fast enough to balance their speed with the pull of gravity to keep them in place, orbiting the Earth from a constant distance.
And so, humans found the way to reach beyond our planet and explore space. Today, thousands of satellites orbit the Earth. Humans live on a space station, hovering in the skies. We have landed on the moon, explored the surface of Mars, and launched telescopes that peer into the deepest reaches of the universe. Rocket evolution and space exploration continue to this day. Deep space probes, Mars rovers, reusable rockets, and even space tourism have turned science fiction into science fact.
So now we know, spaceflight is the culmination of decades of technological achievements, all building upon each other to advance science, exploration, and our knowledge of not just our own world, but of our universe. Space has been called the final frontier, but as we continue to push the limits of our understanding and capabilities, the universe continues to teach us more and more about life here on Earth. The science of flight is the story of human achievement, drive, and creativity. From hot air balloons to space, flight has been the vehicle that pushed science to incredible heights. We hope you enjoyed our Science of Flight series. Follow along with us as we learn more about the world around us. Travelparkourist, learning as we go.
Beetlejuice, supernova,